Good day, everyone, and welcome to where we are putting together solutions for students who are getting major problems in the area of mathematics at the CSEC or Caribbean Secondary Examination Council level, which is normally known as the Form 5 or O levels. We also have channels to help students who are struggling in the areas of additional mathematics with all the solutions from when Add Maths started in May 2012 until present. And we have another channel for those students who are struggling in the primary area for the SEA. This video will be looking at May 2023, that past paper, and specifically the entire of paper 2. Don't forget to like the video and add any comments down below so that we can help you by creating other videos to assist in whichever areas that you are struggling with. Links to all these channels as well as all the topics in CSEC Math are in the description down below. Note that there are 17 topics and each topic has a playlist with approximately 10 to 12 years past paper solutions only in that topic, along with notes to go with it for students who are struggling. And from this year, May 2023 onwards, we'll be looking at entire solutions for students who, after they've done the playlist, come now and go through an entire paper. Let's now start by looking at the actual mathematics syllabus. And we'll be seeing that there are 10 major topics. And within those topics, we can also see that they're being assessed via paper 1, which is 60 multiple choice questions. And we can see how many questions per topic is assessed. And that is worth 30% or half of it, 30% of the final grade. And paper 2 is a total of 100 marks, which is worth half of that, 50%. So we have 30 and 50, 80% of our final grade comes from paper 1 and paper 2. And then the remainder, which is 20%, comes from paper 3. Paper 3 is normally, if you're in school, doing a school-based assessment or SBA, which is an in-house project. Or there's an alternative paper for those students who have no SBA or who did the SBA and failed, or we use the SBA more than twice, or the SBA is greater than 2 years old. So our first topic in paper 2 is with 9 marks and is made up of number theory and computation and consumer arithmetic. And with a change in the syllabus, the topic of sets is no longer assessed in paper 2, while the topic of measurement is assessed for 1 question with 9 marks, and statistics is assessed for 1 question as well with another 9. Algebra in this paper came as number 2, this with 10 marks, and relations and functions and graphs with 20 marks in this paper, which is actually 2 questions. Question in the first section with 8 marks, and number 8, which is with 12 marks. The next topic, geometry and trigonometry, came as 2 questions as well in section 1 of the paper, which is from the first 7 questions. 1 question came with 9 marks, and in section 2 is made up of 3 questions, 8, 9, and 10. And in this paper, we have to do all 10 questions. So in section 2, it was a heavier weighted question, so it was worth 12 marks. All 3 questions, 8, 9, and 10, are worth 12 marks. The last question on the paper was vectors and matrices with 12 marks. And there's a question which came in this paper as number 7, which is the investigation question with 10 marks. And that could be made up of any of the 9 topics above. So now, let's move on and we actually start the paper. After we did that recap, where in number 1, part A, find the exact value of 5/6 plus 2/3 minus 12 over 35 multiplied by 7 over 9. And if we look at this, we can see that there are multiple operations. There's an addition, a subtraction, and a multiplication. And according to the order of operations, which operation should we do first? It will be multiplication. So what we can do is put brackets around it to emphasize that let's work out the multiplication first before we go on and do the addition and subtraction. So let's bring up a little working column and let's try and work out 12 over 35 multiplied by 7 over 9. And there are a couple of different ways to do this, just like in every topic in math. One of the ways would be that we can reduce it. So what number could go into 7 and 35? 7. 7 into 7, 1. 7 into 35, 5. What number could go into 12 and 9? Well, that would be 3. So 3 into 9 is 3. 3 into 12 is 4. Is there anything that can be reduced again? 1, 4, 3, 5. No, nothing else. So then we can multiply the numerators. 4 ones are 4 and 5 threes are 15. As such, what we have in the brackets worked out to be 4 over 15. Now, let's rewrite that. So we will have 5/6 plus 2/3 minus 4 over 15. And now there are different ways to do this as well. We can use our calculators, of course. But we just want to make sure the concept is really understood by students. So if we look at 5/6, we have sixths, we have thirds, and we have 15ths. We have 3 different sets of fractions. And how would we be able to add or subtract them? We must have something that is common. So there are a couple different ways to do this. One of the ways is consider that if we have sixths, so we have 6 blocks there to represent 6. And we can, of course, identify 5 out of those 6 to give us 5/6. If we have thirds, we can take those 6 blocks and cut it up into 3 parts. And then we can identify 2 out of those 3 parts. What about 15s? Can we take 15 and cut up the 6 into 15 parts? It's going to be difficult. So what we can do, we have 6. Let's add another 5 and 1, 6. So we have 6 and 6, 12. Now that we have 12, can that be cut up into 15 parts? Not as whole numbers. So we add another 6 because we're counted in sixes since we have 5/6. So that's 6 and 6, 12 and 6, 18. 15 can't go into 18. Let's add another 6. So we get 24. 15 can't go into 24 exactly. So let's try another 6. So that is 30. Can 15 go into 30? Yes, it can, exactly. So 30 is actually going to be what we consider our LCM, our lowest common denominator. Now, of course, there are other ways to do it. Just want to bring it up practically so you can see what it looks like. So we can split this up into 6. By going straight across, we have split it up into 2. And if we come down with 2 lines, then we actually have 6 parts. Now we're interested in how many of those 6 parts? 5 of those 6 parts. So we have 1 part, 2 parts. Each part consists of 5 blocks, 3 parts, 4 parts, and of course 5 parts. So this indicates here that we have 5 out of 6 parts. And if each part is 5 blocks, then we actually have 5 5s at 25 out of 30. So 5/6 is also equivalent to 25 out of 30. Or we can write it this way. We have 6, 12, 18, 24, 30, 36, and so forth. And 15, 30, 45. So we can see 30 is common to both of them. And it's the smallest common one. The next number would be 60, which will be common. So the smallest or lowest common denominator is the LCM. It can also be done that way. So what it means that we want to convert each of the fractions to something out of 30. Another way you can do it is 5/6 will be something out of 30. So how do we go from 6 to 30? In the denominator, we can multiply, because we're getting bigger, by 5. So if we multiply by 5 below 6, 5s are 30. Then we can multiply by 5 on top. So that will give us 5 5s are 25. So therefore, 5/6 is equivalent to 25 out of 30. So we can show it a couple different ways for you. Now they've converted 5/6. What about 2/3? So if we remove that and we take off the line, we actually have it broken up into 3 parts. So 2/3, 1/3 will be this first part, which is 5 and 5, 10 blocks. And if we want 2/3, we have another set. So that'll be another 10 blocks. So we have 20 blocks out of 30. So 2/3 is also equivalent to 20 out of 30. And finally, 4/15. So let's remember that 2/3, we can do the same conversion here. How do you go from 3 to 30? We multiply by 10. So 3 tens are 30. And similarly, 2 times 10. 2 tens are 20. So 2/3 is equivalent to 20 out of 30. We can now break it up into 15ths by introducing these lines. 1, 2, 3 parts, 4 parts, 5 parts, 6, 7, 8. And if we keep splitting it, we actually have 15 parts. So each one of those, which is made up of 2 blocks, indicates that is a 15th. So we have 4/15, so it'll be this first set here, right? Which will be 8 blocks out of 30. So you see, we've always selected out of 30, that is our common denominator. So now we could solve 25 plus 20 minus 8. You can say 20 minus 8 is 12, 25 plus 12 is 37, right? Of course, let's do the conversion just to make sure you're okay with it. 4 out of 15 is something out of 30. 15 times what? 15 times 2 is 30. Therefore, 4 times 2, because if you multiply by 2 below, you multiply by 2 on top, will be 8. So it confirms our 8 out of 30 equivalency. Now we can solve, and that'll give us 37 out of 30. 37 blocks out of 30 blocks mean we have an entire whole, and we have 7 blocks remain, so 7 out of 30. Right, so you could have done that with your calculators or confirm it. Let's go on to part B. Part B is broken up into smaller parts. Into part 1, B part 1, calculate the value of the square root of 1 minus cos 37 squared, correct to 3 decimal places. So we can rewrite that. And of course, we can use our calculators. And that will be 1 minus 0.6378. Or if you know your trigonometry rules, that's actually equivalent to sine 37. So that works out to be 0.3622. And the square root of that is equal to 0.6018, continuing. And how do we know where to stop? They're asking us to give an answer to correct the 3 decimal places. So let's put 1 more in our answer, just for safety. So we'll put it to 4 decimal places, 6018. And let's consider now, we want that to 3 decimal places. So that's 3, the third number after the decimal point, which is 1. So we've underlined that. Now, if we're going to write it to correct the 3 decimal places, it means the answer is going to fall into a particular category. It will either fall into the point where it is 0.601, it is close to that, or it is close to 0.602. So our answer must either be one of these, because we wanted to correct the 3 decimal places. Now, the issue for some students is some of them can easily identify where it is closer to. Whichever one it is closer to is our answer, but some get difficulties. So we can add a 0 here, 6010, 6020. So if we consider that now, what's the middle of 6010 and 6020? What's the middle of 10 and 20? That will be 15. So 6015. So that tells us that's our benchmark, the middle. So now if we have 6018, where does that 8, let's highlight that. We'll change the color so you can see it. That 8 is important. So now it tells us that, listen, it falls somewhere to the right of that middle line. If it falls to the right of the middle line, is it closer to 601 or is it closer to 602? Clearly, we can see from this that it's closer to 602. So the approximate answer, because we're approximating it to 3 decimal places, is 0.602. Let's go on to B, part 2. Write the number 0.0527 in standard form. So let's bring up the number, space it out a little bit, and let's put the place values on top so you can remember. For the first number on the left, for ones, and then tenths, and then hundreds, and then thousands, and so forth, 10,000s and go on. I've stopped here at the first number, which is not 0 or non-zero. and that first number is a 5. So we actually have 5 thousandths. So if we rewrite this, we can write it as 5.27 thousandths. And thousands can be written in words or can be written as 1 over 1,000. And what is 1 over 1,000? 10 to the power minus 3. Now that we've completed 1a, let's move on. Where 1c now, Harish, this is the consumer arithmetic part of the question. Harish works at a call center for 35 hours each week. He is paid an hourly rate of $11.20. So we can bring up, let's represent that. Right? Part 1 asks us to calculate the amount of money Harish earns in a 4-week month. So let's represent this now by recognizing that there are 35 hours each week. So if we bring up 7 hours for Monday, 7 for Tuesday, Wednesday, Thursday, Friday, we can approximate it. Some days he may make more or less. Then 7 fives are 35 hours. And what do we know? If we consider that each block represents an hour, that he worked an hourly rate of $11.20. So each block tells us that he got paid $11.20 for that particular hour. So we're asking us to figure out how much money he worked for in a 4-week month. So the weekly wage, how much did he work for the week, is the number of hours that he worked multiplied by the hourly rate. So we can see he worked 35 blocks. So that will be 35 hours multiplied by 11.20. And you can use a calculator, you'll get $392. That's his weekly wage. And if you go back to the question, we want to find out how much money he works for a 4-week month. So 1 week he worked for $392. As such, his wage for 4 weeks will be 4 times $392, which by calculator, or you can work out, is $1,568. So that gives us our answer for part 1. Now for part 2. In a certain week, Harish works 8 hours overtime. So that means he worked his 35 hours and he did 8 extra hours. We already had 7 going across, so we added 1 more. And we changed the color so you can see overtime is in purple. Now that we recognize that, what else do we know? Overtime hours are not paid at the normal amount, but are paid at 1.5 times the usual rate of $11.20. So instead of $11.20 per hour, he's getting more. He's getting 1.5 times that. So what we're going to do, we're going to take that block and make it 1.5 times bigger. Right? So if we multiply by 1.5, then let's make it a little wider so you can see that it works more. As such, find the total amount of money Harish is paid for that week. So for that week, he works for the 35 hours above in our little teal color, and he works for these 8 blocks, which are purple, which are worth even more. So his gross wage, his total wage for that week will be his normal weekly wage, which we have in teal, plus his overtime wage. And that is $392 because we worked that out in part 1 already, plus his overtime wage. And how much money did he work for the purple amount? Well, that would be 8 hours at 1.5 times that, because it's not the 8 normal hours. We have an overtime rate at $11.20. And you can write that in any order. So using our calculators, that works out to be 392 plus $134.40. So our gross wage for that particular week where he worked 8 hours overtime is $526.40. Let's now go on to the algebra question, which is in number 2, where they're asking us to simplify 4 over 5x multiplied by 15x over 16. So let's rewrite it. And what can we do? Just as what we did in number 1a, where we have multiplication of fractions, we can see if there's any way we can reduce it. So what can go into any of these things? If we look at it, we have an x in the denominator, we have an x in the numerator, so they can cancel or reduce. And there's a 5 in the denominator and a 15 there. So if we divide by 5x below, that will give us 1. And 5x into 15x, the x's cancel, 5 into 15 will give us 3. Anything else can reduce? Let's look at it. Can you 3 and 16 reduce? No, they can't. Can you 4 and 16 reduce? Yes. So 4 into 4 Right? Will be 1. 4 into 16 will give us 4. Anything else can happen? Any other reduction taking place? No more. So now we can multiply the numerators. 1 by 3 is 3. 1 by 4 is 4. So part A simplifies to 3/4. Now let's move on to part B. Solve the inequality 12 minus 4m is less than or equal to 5 minus 8m. So if we rewrite that, what can we do? We can make all the m's on one side and all the numbers on the other side. So if I have minus 8m on the right hand side, I can add 8m to both sides. So that means I'll have 8m minus 4m on the left, and 8m minus m will cancel off on the right. And if I have plus 12 on the left side, I can minus 12 from both sides. So that gives us 8m minus 4m. And if we minus 12 from both sides, the 12 on the left side will disappear. So we have 5 minus 12 on the right-hand side. 8m minus 4m now is equal to 4m. So 4m is less than or equal to minus 7. So we want m now. We can divide. M is less than or equal to minus 7 over 4. Now let's picture what that means. So for better understanding, let's bring up a little number line. We know minus 7 over 4 is minus 1 3/4. So that's somewhere between minus 1 and minus 2. Right? And let's break that up a little bit and make a little sketch so students can get a better grasp of what's happening here. And we broke that up into 4 parts. Minus 5/4, so minus 6/4, minus 7/4. That's the order until minus 8/4 is minus 2. So if we're saying it is minus 7/4, that's a key value. So we could put a circle there to indicate that. And it's saying that m is equal to minus 7/4. If it's equal, when we're dealing with inequalities, then we have to shade that circle. And now it's saying it's not just equal to minus 7/4, it's also less than 7/4. If you look at the arrow, it means pointing to the left. So we can draw an arrow as such. Therefore, our inequality, which we have solved, is telling us that if m is equal to minus 7 over 4, or any number to the left, the inequality will work. But if it's any number to the right, it will not work. So let's try it. If we say m is minus 2, and we put it into the first line, then 12 minus 4 times minus 2, that's 12 plus 4 2s are 8, so 12 plus 8 is 20. Is 20 less than or equal to 5 minus 8 times minus 2? 8 2s are 16, so 5 minus a minus a plus, so 5 plus 16 is 21. 20 is less than or equal to 21, so it works. If you try for minus 1 or 0, anything to the right of it, it will not work. If we put 0 in there for m, then we're left with 12 is less than or equal to 5, and that's not correct. So the inequality works when m is less than or equal to minus 7 over 4. So let's go on to 2 part C. The diagram below shows a compound shape, L, M, N, P, Q, R, made from 2 rectangles. The length in the diagrams, which are written in terms of x, are in centimeters, and I'll bring them up one at a time. Lm is 4x minus 5. Mn is 3x. Pn or Np is x plus 1. And Lr or Rl is x plus 3. Find an expression in terms of x for the length of PQ, and we'll highlight that with being a green length. And if we think about it, let's consider it to be up and down or vertical. If we have PQ, we don't know that length, but we know the entire length MN. So we'll have that in black, and LR in orange. So if we move all those things across to the right, let's move the teal across and move the orange across. Hopefully we can see that if we take the orange length and the teal length, we can find the total length, which is in black, if we're just using colors to explain it. Or we want to find the teal length, which is PQ. Then we can take the whole length, which is in black, and minus the orange. So let's write that. The teal, which is PQ, is MN, which is in black, minus the orange, which is LR. And what is MN? MN is 3x minus, let's substitute, x plus 3. And if we're minusing brackets, then we need to expand the brackets. That minus is minus 1 times x, and minus 1 times plus 3. So 3x minus x minus 3, and we can simplify. That will give us 2x minus 3. As such, PQ is that length, 2x minus 3. Part B now, find an expression in terms of x for the length RQ. So RQ, we have that in blue. We don't know that length. That's going horizontally or left to right. But we know the entire length LM in red and PN in yellow. So if we do something similar to what we did just now, let's bring all across. So we can see the blue plus the yellow is equivalent to the red in terms of length. What do we want to find? We want to find the blue length, RQ. So if we have the red length and we minus the yellow, it will give us the blue. So we can say RQ is LM minus the yellow, which is PN. So if we say, we can now substitute, we can say 4x minus 5 minus, what is PN? X plus 1. So we can expand the brackets, just as we did before, multiply by minus 1. We're going to get 4x minus 5 minus x minus 1. And if we simplify, 4x minus x is 3x minus 6. And that is the length of RQ. So for part C, part 1, A and B, we've solved. Let's now move on. Let's leave the diagram there again, 4x minus 5 and so forth. Just rewrote the lengths LR and PQ slightly differently. X plus 3 and 2x minus 3, they're all there. Part 2 now of C. Given that the total area of the shape is 414 centimeters squared, so when we consider area, we actually considering what's the unit? Centimeters squared. So a centimeter by a centimeter, those little squares. If we were to cover the shape, we needed 414 of those. So show that x squared plus x minus 72 is equal to 0. So this is the area. Let's cover that part in terms of a peach rectangle and the other part in terms of a yellow rectangle. And if we covered both areas, this compound shape can be broken up into two rectangles, as said in the first line above. Then the total area is the area of the peach plus the area of the yellow. So the total area will be length times breadth for the peach, right? And similarly for the yellow, length times breadth. So 4x minus 5 by x plus 3 for the area of the peach. And we can work that out using FOIL, using expanding there. I want to do it a little differently by breaking it up into 4 little rectangles. They're not really the same, it looks like that. So if we look at this here, can we find the area of each of these small rectangles? The top small rectangle in the peach area is length by breadth 4x times x, which will give us our total area here is 4x squared. And if we look at the right-hand side top rectangle, what's the length and breadth? Minus 5 times x, which is minus 5x. And the bottom left side, length and breadth will be 4x and 3. So 4x times 3 is 12x plus 12x. And the bottom right side, plus 3 times minus 5 for length and breadth, minus 15. So we're able to actually come up with that version of expanding the brackets. So we have 4x squared minus 5x plus 12x minus 15. Or some people can simplify the x's and get plus 7x. That's fine. Let's do the same with the yellow area. And if we do that, the top left side of the yellow area will be 2x times x, which is 2x squared plus 2x squared. And the top right side is plus 2x times plus 1 is plus 2x. And the bottom right side is minus 3 times x is minus 3x. And the bottom right side minus 3 times 1 is minus 3. So we can bring that up. And now that we have these 8 terms, of course you could have simplified it, that's fine. Now, the total area we can now simplify. And we know it's 414. It's 4x squared plus 2x squared. We're putting the same terms together. Minus 5x plus 12x plus 2x minus 3x minus 15 minus 3. And if we simplify, 4x squared plus 2x squared will give us 6x squared. Minus 5 plus 12 will give us plus 7. Plus 2 is plus 9. 9 minus 3 is plus 6. Minus 18. And we're bringing the 414 across to become minus 414. Now, what we can do is simplify. So that will give us 0 is equal to 6x squared plus 6x minus 432. And if you look at what is above, where they're asking us to show that 0 is equal to x squared plus x minus 72, then how do we move from this form to that form? If we look at the coefficient of x squared, which means the number in front of x squared, presently we have 6x squared, and we would like to end up with 1x squared. So what we can do is divide throughout by 6. So 6 into 0 will still be 0. 6 into 6x squared will be x squared. 6 into 6x will be x. And 432 divided by 6 is minus 72. And this is exactly what we have above. So let's repeat the question. Given that the total area of the shape is 414 centimeters squared, show that this quadratic is equal to 0. And we have just done that. So when we have completed a proof, we can now write QED to show that we have completed it, which means quod erat demonstrum in Latin, or we can draw a square. Let's now move on. So in our next number, a diagram below shows a semicircle with diameter AC. So we can see the semicircle and we can see a line straight across from A to C being our diameter. B is a point on the circumference, and AB is equal to BC. So where we have our lines from A to B and from B to C, to show that they're equivalent, we can have those little hatches or those single lines on each showing that they're the same length. And what is the length? 8.2 centimeters. Part 1. State the geometrical name of the line AB. Now, some students can tell what it is exactly. Others may need to recall that this is part of an entire circle. And when we are moving from one point of the circumference to another point on the circumference, like A to B, and moving across in a straight line, what is that line called? AB is a chord. And the longest possible chord you can get in a circle will be the diameter, AC. Let's now move on to part 2. Find the value of the radius of the circle. So I brought up R there. We've put that onto the diagram so you can get a visual representation of what's happening. And remember that this, from the rule, is a right angle triangle. And why is that? Because any triangle formed in a semicircle is a right angle triangle. So that means the angle at B, or we can refer to it as ABC, that angle, is 90 degrees. So if we want to find the radius of that circle, we can easily see that it falls within the periphery of that triangle where ABC is a right angle triangle. So now, what can we do? Since we know two lengths, we can say from Pythagoras' theorem, O squared plus A squared is equal to H squared, or any other versions that you know. And if we substitute, AB squared plus BC squared is equal to AC squared. And we don't know AC, but we know the other two. So if we know two sides in a right angle triangle, using Pythagoras' theorem, we can find the third side. So we can substitute what is AB? 8.2 squared, and BC, same, is equal to AC squared. And if we use our calculators and work that out, that'll give us 134.48 is equal to AC squared. So if you want AC, we find the square root of that, which works out to be 11.6. So from A to C straight across is 11.6 centimeters, which is 2 radii. And what does the question ask? Let's go back to it. Find the value of the radius, meaning what is the value of 1r? So if 2r is equal to 11.6, then r is equal to 11.6 divided by 2, which will give us 5.8 centimeters. So that's the radius of the circle. Let's now go on to the next part. Each interior angle of a regular polygon is 160 degrees. Calculate the number of sides of the polygon. So let's just recall how the formula came up. If we consider we have a triangle, how many sides does the triangle have? Well, n, the number of sides, is 3. And that means there's one triangle in there. So that means the total internal angle is 180 degrees. So we have 3 angles in there adding up to 180. So if we want to find for one of the interior angles, because we're considering this to be a regular triangle, meaning it's an equilateral triangle, 3 into 180 will be 60 degrees. Now, let's say that we move from a shape with 3 equal sides to a shape with 4 equal sides. So it'll still be a regular shape, and that'll be our regular polygon or regular quadrilateral in this case, normally known as a square. And how many sides does it have? Well, n has 4 sides. And how many triangles can we get inside of the square where we're starting from one corner and moving across to another corner? So let's draw a line like that. So we can see we can subdivide this square into 2 triangles. And if we have 2 triangles, it means 180 plus 180 is 360 degrees. So the total internal angle inside a 4-sided figure is 360. Let's do another one. If we did 3 sides, we did 4 sides, let's bring up now a pentagon. And the pentagon will have 5 sides. And if we do the same thing, we want to find the total interior angle, then we could start at one corner and extend the line across to another corner and continue like that. And there's only 3 triangles we can get in there, which means that 3 times 180 is 540 degrees. And if there are 5 equal sides, then each angle is equal. So 5 into 540 is 108 degrees. Now we'll do one more. So if we had 5 sides, let's bring up a 6-sided figure. So our hexagon here will have 6 sides. And if we take the corner again and we extend to get triangles, we could go down, we go across, and then we go further to the right. So we could have 1, 2, 3, 4 triangles. And if we had to work out for this here, where we have a regular hexagon, we have 4 triangles, so 4 times 180, which is 720 degrees. And there are 6 possible angles. So if we want to find out how much for one angle, well, we divide the 720 by 6. So each angle was 120 degrees. So hopefully we can see a relationship between n, the number of sides, and the number of triangles. And for each case, the number of triangles was 2 less than n. So how do we get the total amount of angles in there? We take the number of triangles and multiply by 180. That's why we have this general formula, n minus 2 times 180 is equal to n times the interior angle, which in this case is 160. So if we now expand and solve, we can multiply 180 on the left-hand side by the brackets, so it'll give us 180n minus 180 times 2, which is 360, is equal to 160n on the right side. So we can now move all the unknowns onto the left side and the knowns to the right. So we have 180n, carry across the 160, so it'll be 180n minus 160n is equal to 360. And 180n minus 160 will be 20n is equal to 360. So n, which is the number of sides, will be 360 divided by 20. As such, for an interior angle of a regular polygon with 160 degrees, this shape must have 18 sides. Let's now go on. Let's now look at number 3. See, the diagram shows a trapezium A drawn on a square grid. On the diagram, draw the image of A after it undergoes a reflection in the line x is equal to minus 1. And label this image A prime. So where would we find x is equal to minus 1? Well, we'll have to look on the x-axis, which is the horizontal axis, the one going from left to right. And we move across and we find the point where x is equal to minus 1. And that line will be anything vertically running up and down, passing through that. So let's bring up that line. So now if that is our mirror line, and we want A to be reflected about that line, A is on the left-hand side. When it's reflected, it should end up on the right-hand side in the first quadrant. Now, let's pick one point on A. We could see on the bottom right side of A, we have a point. It's 2 blocks, so 2 units away from the mirror line. So by the time we reflect that, it should end up 2 units on the right of the mirror line, which would be at the point 1. So let's do that reflection. Let's bring up A, and by moving it across, right, and reflecting it, you'll end up facing the other direction. And we could see that bottom corner of A on your bottom right side was at minus 3, 2 units away from minus 1, and by the time we reflected it, it ended up at plus 1. So that's the reflection. Now let's go on to part 2, where we're saying on the same diagram, draw the image of A after it undergoes a translation with vector in the line 4 minus 7. And label this image A double prime. So we're not starting at A prime, we're at A. And we want to move 4 minus 7. What does that mean? Using this column vector, moving plus 4 means moving 4 units to the right. So if we take that bottom corner and we are now translating, if we look at translate, there's a SL in it, which means to slide. So we're sliding the whole thing across 4 units. So from minus 3, it went minus 2, minus 1, 0, 1. So it's 4 units across. And then minus 7 means we're moving 7 units down. So at minus 2, we go 2 units down to the x-axis and then 5 more. 2 and 5 is 7. So what we're trying to do is take A, so let me bring up A, and slide it across 4 to the right and 7 down. And that will be A double prime. The next question, where it says consider the following functions. And in this case, we have 3 functions. The first function, f of x, which is a fraction. So this algebraic fraction has x in the denominator. G of x, simple linear equation for x minus 5, and h of x is a quadratic equation, x squared plus 1. So now the question is asking us in part A, for what value of x is the first function, f of x, undefined? Undefined means that when we put a particular value for x in that first function, we will not get an answer. Or if we put it into our calculators, our calculator will tell us it's an error. So we have the function f of x, and that is undefined when the denominator is 0, because whatever division we have, when the denominator is 0, it gives us an error, or it is undefined. So when does our denominator x plus 2 equal to 0? That is the case when x is equal to minus 2. So we've finished part 1. Let's go on to the next part. Find the value of g of a quarter. So many times when you look at the playlists where we've done functions, I normally bring up a flow diagram to represent it. But I'm thinking we're accustomed to that. So g of x is equal to 4x minus 5. It means if our input is x, what do? We are saying 4 times that minus 5. So let's write the function first. So g of a quarter would mean 4 times a quarter minus 5. And 4 quarters is a whole. So 1 minus 5. And 1 minus 5 is minus 4. So we worked out part A, g of a quarter. Now let's move on to part B. We now have to find the value of h of minus 3. So let's write down this h of x equation, which is a quadratic, x squared plus 1. And what it's telling us is if our input into the function is x, whatever number it is, the first thing to do is square it and then add 1. So if we have minus 3 as our input, then we're going to say minus 3 squared plus 1. And minus 3 times minus 3 is plus 9. So 9 plus 1 is 10. So we solve for h of minus 3. Now let's go on, where in part C, it's a composite function, where it's one function operating upon another function. So the first function is f of 0, and we're now, when we get that answer, we are now going to put f upon that, a second f function. So if we consider writing the equation f of x, which is 3 over x plus 2, and our input is 0, wherever we have x, we're going to replace it by 0. So f of 0 is 3 over 0 plus 2. So that means the denominator works out to be 2. So f of 0 is equal to 3 over 2. As such, when we look at the composite function f of 0, we can take out f of 0, which is on the right-hand side. This sort of works backwards from right to left. Then f of 0 is 3 on 2, so we can replace that. Let's do such. So it'll be f of 3 on 2. So let's write the function again. And our input now is 3 over 2. So f of 3 over 2 is 3 over 2 plus 2. 3 over 2 plus 2 in the denominator would be 3 over 2 plus 4 over 2, which is 7 over 2. So 3 divided by 7 over 2. And of course, when we're dividing fractions, we can multiply it and get the reciprocal when we're working it out. So 3 times 2 over 7, and that works out to be 6 over 7. So the f of 0 is 6 sevenths. Let's go on to the next part of number 4, where they're asking us in part B, write an expression in its simplest form for the composite function g h of x. So first thing of all, let's look at the idea of g h of x. What does it mean? It means our input is x, and then we're going to apply the function h on it. So x will be the input for h. And so we could write that h of x is equal to x squared plus 1. And now that we know x squared plus 1 represents h of x, we can now say g of such. So if we replace h of x, then that gives us g of x squared plus 1. So x squared plus 1 is the input for g. So let's write the normal function g of x equal to 4x minus 5. And what happens? Our input is no longer x, it is x squared plus 1. So if we consider applying the flow diagram here so you could get a better idea of it, remember we spoke about this already when we worked out in the first part, in part A, that if we have the input for the function g, we're going to multiply it by 4, and then what are we going to do? We're now going to subtract 5. And if we multiply by 4, so we take x, we multiply by 4, that's 4x, and we minus 5. What does that give us? It gives us our output. And our output is g of x. So if it is that we want g of x squared plus 1, that means our input is x squared plus 1. And what do? We take whatever our input is and multiply by 4. So it'll be 4 times x squared plus 1 minus 5. And now it's simply expanding the brackets and simplifying. So 4 times x squared is 4x squared. 4 times plus 1 is plus 4 minus 5. So that will give us 4x squared minus 1. And that is gh of x. So that's the simplest form to represent this composite function. Now let's go on to the next part, where they're asking us to find g inverse of minus 2. Now we have the flow diagram there showing us what g of x is. If we're going from left to right, our input is x, we ended up with our output of g of x. But in this part C, we want to find the inverse function. What does it mean? It means since g of x is equal to 4x minus 5, that if we go in the opposite direction, then that will tell us what g inverse is, to do the opposite. So when we're starting on the right-hand side, so we always say our starting point is our input as x, and we do everything backwards. So instead of minusing 5, what's the opposite of that, or the inverse of such? It means to go and add 5. And we're saying that in order to deal with the inverse of g, then we take x and we add 5, and then do what next? Instead of multiplying by 4, we divide by 4. And then what will that give us? It will give us our output. And our output is the inverse function of g. So now g inverse is x, add the 5 to it. And when we get that answer, what do? We now come and divide by 4. So g inverse of minus 2 means we're putting in minus 2, that's our input, and we're adding 5 to it. And then when we get our answer, divide by 4. Minus 2 plus 5 is 3, so it'll give us 3 over 4, or 3/4. Let's now go on to the next question, which is number 5. Each of 75 girls recorded the name of her favorite sport. The number of girls who chose track and cricket are shown on the bar chart below. And we can clearly see that. How many more girls chose cricket than track as their favorite sport? So if you want to work that out, we can draw a little line across or take our ruler and make sure that we're accurate so we can see where it indicates how many students chose cricket, which is 17. And similarly, we could tell from track that it is 12. So we say how many more? What's the difference? So it's 17 minus 12, which works out to be 5 girls. Now let's go on to part B. 11 girls recorded tennis as their favorite sport. So let's bring that up. Let's draw that on the chart here. So what that tells us is our total students who chose tennis, track, and cricket are 11 plus 12 plus 17. 11 and 12 is 23, 23 and 17 is 40. So we have 40 of the girls who chose these 3 items. For the remaining girls, not those 3 sports, all those who chose the other things, which are swimming and football, for these remaining girls, the number who chose swimming compared to the number who chose football was 2 to 3. So what does that mean? It means that, let's just put a little arrow just to give us an idea that we have an average amount of girls who did swimming. We don't know how much it is. We don't know how high we're going to be able to draw this bar to represent such. But we just want to say, since the ratio is 2 to 3, if swimming is 2, football is 3, does that mean that's the same amount of girls who are choosing football and swimming? If that was the case, it would be 2 to 2. No, it's 2 to 3, which means that if we have to represent it with an arrow for football, it will be an arrow which is taller. So when we're drawing our bars to represent these two areas, then the bar on the left representing swimming must be shorter than the bar on the right in the ratio 2 to 3. So what do we know? It's the remainder. Since 40 students chose tennis, track, and cricket, the remainder from 75 will be 75 minus 40 is 35. So 35 girls chose either swimming or football. So now the question is asking us, use this information to complete the bar chart. So we know 35 girls did swimming and football as their choices of their favorite sport, but how many of each? So we know the ratio. Swimming to football will give us the remainder, the 35. So the ratio is 2 to 3. So 2 parts to represent swimming, the 3 parts representing football will be 2 plus 3 is 5 parts. And what is these 5 parts? That is the remainder, which is 35 girls. So we can basically have an equation here showing that 5 parts represents 35 girls. So 1 part, using unitary method, finding for 1, with 35 divided by 5, which means that 2 parts would be 2 times 5 into 35 is 7. 2 sevens are 14. So that's telling us that there are 14 girls who chose swimming. And we can now draw a bar to represent such. So we can easily see where 14 is. So there are more girls who chose swimming than tennis or track. And we now need to work out for the last one, football. Since there are 14 girls who chose swimming, and swimming and football is 35, then we can find out for football. So football will be 21 girls. And we can draw that as well to complete the bar chart. Let's now move on to the next part, where they're asking us to determine the modal sport. The modal sport is the sport which has been chosen as the most frequent. So which of these, swimming, tennis, track, cricket, or football, which one of those five is the most favorite or the most chosen or most frequent? And that will clearly be football. Let's go on to the next part of number 5, where in part D, one of the girls is selected at random. What is the probability that she chose neither track nor cricket as her favorite sport? So she did not choose track, let's put an X there, and she did not choose cricket. So if she did not choose track or cricket, she had 3 other choices. So neither track or cricket, neither of them would be swimming, 14, tennis, 11, or football, 21. So then it would be a total of 46. So what is the probability that she chose neither track or cricket? 46 students chose that. And probability is a fraction which represented, so it'll be 46 out of 75 girls in all. Going to the next part, where it says the information on the favorite sport of the 75 girls is to be shown on a pie chart. Calculate the sector angle for football. Now it's telling us that we don't need to actually draw the pie chart, but we're going to set up one so you can get a grasp of what's happening. So if we start with a pie chart, let's draw a circle here as a little freehand sketch. And what does that entire circle represent? 75 girls. So that means 75 girls is equal to the entire circle, which is 360 degrees. So, using the unitary method, meaning finding for 1, then 1 girl will be 360 degrees divided by 75, and we can work that out, or we can just continue because we want to find for football. For football, if we look from our bar chart, we can see it's 21. So for 21 girls, it will be 21 times 360 degrees divided by 75, which works out to be 100.8 degrees, which will be represented in green there if we actually had to draw the pie chart. We now go on to number 6, where the question says, it's telling us that we must take pi to be 22 over 7, not a decimal in this case, and the volume, V, of a cone with radius r and height h is given as V is equal to 1/3 pi r squared h. The diagram shows a sector O, M, R, N of a circle with center O, and the radius is 12 centimeters, and sector angle 168 degrees, which was formed using a thin sheet of metal. Calculate the perimeter of the sector made from the thin sheet of metal. So let's recall what is perimeter. It is the distance around the entire shape. So in order to make it simple for students and to cut out the little errors, we can put a point, let's say X, to indicate where we're starting. And we can go in any direction, go around the entire shape and back to M. So from M to O, and then from O to N. So we have covered one radius, M to O, and then O to N, another radius. And now we go along the arc, and that will give us those 3 sides, the entire distance around, or the perimeter. So MO plus ON plus NRM. We know the first two are radii of the circle, which means that it's 12 plus NRM, the length of an arc. And if we recall in our formula sheet that is given, the length of an arc will be whatever angle is being formed out of 360 multiplied by the circumference, 2 pi r, r being the radius of this sheet of metal. So we can substitute. That will be 12 plus 168 over 360, multiplied by 2, multiplied by 22 over 7, multiplied by 12, the radius of the sheet. And that will give us 24 plus 35.2, So our perimeter is 59.2 centimeters. Let's go on to the next part of the question, where it says a cone is made from the sector in part E by joining OM to ON. So let's bring up that little diagram, and you can see OM was on the left, ON was on the right, and what happened? They folded the sheet, so OM is now on top of ON. So the two radii of that metal sheet overlapped. And if we consider O, M, and ON, M and N being in the same place, then this cone forms a circle at the base, which we have in that color teal. So we have M, and that side will be R, and then N. So it gives us that circle at the base MRN. Now let's recall, since it's a right cone, then we can drop a line from the top at O straight down to the center of the circle. We can call that the altitude, or H, its height, and the radius of the circle is R, and they will form 90 degrees between each other. So it's the perpendicular height. Now part 1 is asking us to calculate the radius R of the cone. The perimeter NRM, which we just worked out in part A, is equal to the circumference of this circle at the base of the cone. And we can substitute. We worked out perimeter in NRM to be 35.2 centimeters, and the formula for circumference of a circle is 2 times pi times r. So we can now substitute. 35.2 is 2 times 22 over 7 times r. If we notice, we have one equation, we have one unknown, so we can solve it. So that will be 2 times 22 is 44 over 7, and we can carry the 7 across. 7 is dividing. When you carry it across, it will multiply. The 44 is multiplying by the r. When you carry it across, it will divide. So it will be 35.2 times 7 over 44 is equal to r. And solving our calculators, and that will give us 5.6 centimeters. Now we move on to part B, where they're asking us to calculate the height of the cone. So we just solve for r. OM is the radius, which we know from before is 12 centimeters, and we want to find for H. And if we look at H and R, we have a 90 degrees being formed there, so we could recognize that there's a right angle triangle. And if there's a right angle triangle, and there's H, R, and we know OM, the hypotenuse of that triangle, let's extract it. And if we take a look at it, we know 12 centimeters. We know R from part A, it's 5.6. So if we know two sides of a right angle triangle, can we find the third side? We can, by using Pythagoras' theorem. So let's bring that up. H squared plus R squared is equal to OM, or the hypotenuse squared. Let's now substitute. So 8 squared plus 5.6 squared is equal to 12 squared. And we know what 5.6 squared is. 31.36 is equal to 144. So 8 squared is equal to 144 minus 31.36. So 8 squared is equal to 112.54. As such, if you want to find H, which is the height of the cone, then it's the square root of 112.4, which works out to be 10.6 centimeters. Knowing that, let's go on to the last part. In part 2, calculate the capacity of the cone in liters. So we know the volume is given in the first line above, 1/3 pi r squared h. And we want to find capacity or volume V. We know pi is 22 over 7. We know the radius r from part A is 5.6. And we know the height, we just worked out to be 10.6 centimeters. So volume is equal to 1/3 times 22 over 7 times 5.6 squared times 10.6. And we use our calculators and we get 348.25 cm cubed. And we want our answer not in centimeter cube, but we want it in liters. So we can first convert centimeter cube to milliliters, because 1 centimeter cube, that space that's being occupied, is the same as 1 milliliter. So 348.25 centimeter cubes takes up the same space as 348.25 milliliters. And if we look at part 2, we want our answer in liters. So how do we convert from milliliters to liters? The difference is 1,000. So 1,000 milliliters makes 1 liter. So if you want to convert to liters, we must divide by 1,000, which means we are moving the decimal point 3 places to the left. And if we do that, we're going to get 0.3 approximated to 0.35 liters. Let's now go on to the next question, where in number 7, this is the patterns question or the investigation question. A sequence of designs is made using black discs and white discs. The first 3 designs in the sequence are shown below. And what I'm going to do is bring them up one at a time and see if we can recognize what pattern is there being extracted. So for design 1, there's 1 black disc, 2, 3 black discs on the bottom row, and then 1 black disc above. And that's all the black discs that there are, forming an L. And now there's a white disc right above it. So we have 3 discs at the base, 3 discs going up vertically. So sort of forms a square. And what completes the design is these 2 white discs. So we technically have it forming into a square where the top row only 1 disc is there, a white disc. Let's look at design 2. It's a repetition of design 1 in terms of black discs, and it expands in terms of 1 black disc goes to the right and 1 black disc goes up. But as usual, we want to maintain that idea of a square. So if we have 4 discs on the base, we want to have 4 discs going up vertically. We have 3 black discs, so we need to have 1 more as a white disc there. So we got that square pattern it falls into, which means that we need to fill the second row with white discs, and then the third row with white discs as well. Now, let's move on to design 3, where it's a repetition in terms of black discs from design 2 to design 3, and it grows by having 1 more disc on the base on the right side. So we have 5 across, therefore we'll need 1 more black disc above. We have 5 across on the base, so we need to have 5 going up vertically. We have 4, so the other disc will be a white disc. And now we can see it forms into that square. And what that means is we need to input 4 white discs on the second row, 4 white discs on the third row, and then finally 4 white discs on the fourth row. Now let's move on to the next part. In the space provided on the grid above, draw design 4. So we had basically a square overall pattern. So in design 4, let's do the same thing. So that's a repetition of design 3. And of course, we're growing 1 to the right and then 1 above. So we get a larger disk. So we get a larger square. So what that means is a repetition of the black disk, and we add 1 to the right and 1 black disk above. Does it form the complete square? We need 1 white disk to make it 6 to the across and 6 upwards. And now we repeat all the white discs, and what we do, we add 1 more disc on either side, and finally a 4th row of white discs. So this has completed the design 4. Let's now move on to the next part, where it says that the number of white discs, W, the number of black discs, B, and the total number of discs is represented by T. And those form each design which follows a pattern. And if we look at the first one, design number P, where it was 1, the first row, we will see we have 3 white discs and 4 black discs. And if we add it up, we'll get the total, which is 7. And in the second one, for design number 2, we have 7 white discs and 6 black discs. 7 and 6 is 13, the total. 13 and 8 is 21, and so on and so forth. So the values for W, B, and T for the first 3 designs are shown in the table below. Study the pattern of numbers in the table. Complete rows 1, 2, and 3 in the table. So if we look at the second column coming down, the number of white discs, W, we can see from rows 1, 2, 3, what are the changes? 1 times 1 becomes 2 times 2 becomes 3 times 3, plus 1 plus 2 plus 3. So where are we getting this difference of 1, 2, and 3? From the first column, 1, 2, and 3. As such, what happens where we have the row with 9? Then it will be 9 times 9 plus 9 plus 1. So 9 nines are 81, and 9 is 90, and 1 is 91. And similarly, we had 20 by 20 plus 20 plus 1. 20 20s are 400, plus 20 is 420, plus 1, 421. So at the bottom, we have n by n, so that's n squared plus n plus 1. And now, if we notice that in order to identify the design number, it will be the first number coming down. So in part 2, we have 20 by 20. As such, that is telling us that our design number is 20. Now let's go to the third column. In the third column, we see a pattern 4, 6, 8, and so forth. So if we go backwards, 8 minus 2 is 6, minus 2 again is 4. So if there was anything before that, we'll minus 2 one more time. And 4 minus 2 is 2. So we can use that to generate our pattern. So now what do we know? We know for the first row, it will 2 plus 1, 2 is 2. So that will give us 4. And it'll be 2 plus 2 2's. So 2 2's are 4 and 2, 6. So by the third one, it'll be 2 plus 3 2's. 3 2's are 6 and 2, 8. And what is changing as we're coming down vertically? The 2 remains the same, the plus remains the same, the multiply remains the same, the second 2 remains the same. What is changing is 1, 2, 3. And it's exactly the same as the first column. So what happens now in part 1 where we go across and we look at the number of black discs? The 2 will remain the same, the plus will remain the same, the brackets and the multiply 2 will remain the same, and the only thing will change will be the 1, 2, 3. It now becomes 9. So it will be 2 plus 9 2's are 18, and 2 is 20. And then if we went to part 2 and we look at where the design number is 20, it'll be 2 plus 20 by 2, which is 40. 40 plus 2 is 42. So by the time we're at the base, it'll be 2 plus n times 2, or 2n. And we now go to the final column. In order to get a total, we just need to add. And we can confirm in part 1 that we are correct, because 91 plus 20 is 111. We did this for rows 1, 2, and 3 already, for 7, 13, and 21. So for part 2, we have 421 plus 42, which will give us 463. And for the final row, we have n squared plus n plus 1 plus 2 plus n times 2, or 2n. So if we add it up, we're going to get n squared plus n plus 2n is n squared plus 3n plus 3. Part C, the last part of this question. Stephen has 28 black discs and 154 white discs and wants to make design 12. Explain why it is not possible for him to make design 12. So if we consider that idea of white discs being 154 with the pattern of 12 being the design number, then W is equal to n squared plus n plus 1. That's our general formula in part 3. We developed that. And we know n is 12 because it's design 12. Then the number of white discs needed will be 12 squared plus 12 plus 1. 12 12s are 144. 144 plus 12 is 156. Plus 1 is 157. So in order to do design 12, he needs 157 white discs. Unfortunately, Stephen only has 154 white discs. So he's short by 3. So Stephen does not have enough white discs in order to make design 12. Let's now go on to number 8, which is actually starts the second section of the paper. All questions being compulsory. Number 8, complete the table for the function y is equal to minus x squared plus x plus 7. So we have this table where we have some of them coordinates already generated, the y values from the x. So what can we work out? We can work out given the function y is equal to minus x squared plus x plus 7 for different values of x. So let's consider when x is equal to 1, the simplest of the values. So let's write the function y is equal to minus x squared plus x plus 7. And we know x is equal to 1, so if we put it in, we're going to get y is equal to minus 1 squared plus 1 plus 7. Minus 1 squared is minus 1 plus 1 is 0, 0 plus 7, so y is equal to 7. So we can put that into the table. So when x is 1, y is 7. When x is 0, y was also 7. So let's go on to the next one. Let's consider when x is minus 1. So if we substitute when x is equal to minus 1 into the general equation that we're using here, this quadratic, then we will have y is equal to minus of minus 1 squared plus minus 1 plus 7. Minus 1 squared is 1. So minus of 1 is minus 1. Minus 1 is minus 2. Minus 2 plus 7 is 5. So since y is equal to 5, we could put that into the table. And hopefully we could notice a little pattern. That we have 7 under x is 0 and 7 under x is 1. And if we go further out, we have 5 and 5. We're looking at the y values. Now let's recall that when we talk about a quadratic equation, it's a parabola. And if it's a parabola, that means there's a middle line or a line of symmetry or an axis of symmetry or a mirror line. So it means there's reflection from the left to the right. So if we consider, I'm putting here dotted line in green, that to the left of it, y was 7, and to the right of it, y is 7. And then we go further out, y is 5, and to the right, y is 5. So if we go further out from that, when y is 1, this means that y is also 1 when x is 3. And we go one more out when y is minus 5 at x is 4 units away. Then we're going to get y is minus 5. So we're able to generate the others without having to calculate because we know that there is reflection taking place about a mirror line. Let's go on to the next part. On the grid, draw the graph of y is equal to minus x squared plus x plus 7. For the x values from minus 3, we're including that to 4. And if we look at our grid, we can see that's our whole x-axis that they've already labeled for us. And notice that the coefficient or the number in front of x squared is minus 1, which indicates that this graph is an inverted U-shaped graph. Right, so let's plot. We know for the first value, x is minus 3. And when x is minus 3, y is minus 5. So we could bring up that point. And when x is minus 2, y is 1. So we could plot that. Next one, minus 1 for x, y is 5. Then when x is 0, which means we're dealing with our y-axis, y is 7. So that's also from our general formulas, y is equal to ax squared plus bx plus c. C is 7, so that's where it's cutting the y-axis. And it says the same here. When x is 1, that means y is 7 as well. There's a reflection. When x is 2, we can see it's at the point where y is 5. When x is 3, y is 1. And when x is 4, y is minus 5. And now if we're going to draw the graph, it means we have to connect. And when we connect it, we could see that it's an inverted U, just as we said, because of the negative sign in front of the x squared, right, with a maximum. So let's go on to part C. Write down the coordinates of the maximum or minimum point. And clearly, it is a maximum point. So we could indicate that here. And it happens when x is 0.5, the middle between 0 and 1. As we could see with the green line in the table, we could have figured that out ourselves. It must be halfway between 0 and 1, which is 0.5. And the y value was 7.2. We could read it off from the graph. If we calculate it using our calculators and substitute 0.5 into there, we get 7.25 as the y value, but it's very difficult to read that off the graph. So from the graph, we'll read it as 7.2. And for part D now, they're asking us to write an equation of the axis of symmetry of the graph. And the axis of symmetry is also the mirror line, which would be where the maximum point occurs, the x value of it. So we could bring that up as a red dotted line. And that passes through the point x is equal to 0.5. So that is the equation of the line for the axis of symmetry. Part E, Use your graph to find the solutions of the equation minus x squared plus y plus 7, or y is equal to 0. So what does that mean when y is equal to 0, or this equation is equal to 0? It is asking us to find the roots of it. So let's identify it. Let's look. There are two roots, which first will be on the left side. The roots mean where the equation cuts the x-axis, and it cuts it at the point minus 2.2. And there's a second root on the right side. We'll indicate it there as well, where x is equal to 3.2. And let's move on now to part F, where it says, on the grid, draw a line through the points minus 3, minus 1, and 0, 8. So minus 3, minus 1, let's indicate that with a gray X, and 0, 8 will be there. And now we drew a line through it. Now that we did that, we follow those instructions. We go on to part 2. Determine the equation of this line in the form y is equal to mx plus c. So if we consider this line here, two points connected by a straight line, then you could see that as being a right angle triangle. And if we're from the bottom left side and we're moving to the right, we're moving how many units across? We're using 3 units across, or plus 3. So the change in x is plus 3. And then when we move across to there and we go up, that will be moving from minus 1 until 8. So we'll be moving, the change in y will be 9. And why do we use that? So that we can now say, we can find the equation of the formula by saying that the gradient is change in y over change in x, which is 1 over 3, and 9 over 3 gives us the gradient m as 3. So it means every time we move 1 unit to the right, we go 3 units up. And that's how steep it is, or that's the slope. And now that we know m, and it is cutting the y-axis at the value 8, so c is 8, then the general equation of a straight line is y is equal to mx plus c, and we can substitute y is equal to 3x plus 8. We've now completed this, and we move on to number 9, where we move into the geometry part of it. And here this question definitely deals with circle geometry, where it says that L, M, N, and R, and if we look at that, forms a quadrilateral. And this quadrilateral is on the circumference of a circle. So it's a special quadrilateral called a cyclic quadrilateral. And there's a particular rule to go with that. Cyclic quadrilaterals, their opposite angles always add up to 180, meaning that their opposite angles are supplementary. And the circumference of this circle that we're looking at, its center is at O, as indicated. PQ is a tangent to the circle, meaning that the tangent forms a 90 degrees with the radius OR, and the angle PRL is indicated as 48 degrees. That angle is the exterior angle of the triangle. And the angle RON is 156 degrees, the angle subtended at the center. So generally when we're doing circle geometry, from our notes, and if you look at our videos on that, there was one video that explained all these rules that was required for our syllabus. And you could look at the playlist to go through all the solutions. We did 10 years of solutions on this. Part 1, find the value of each of the following angles, giving reasons for each of your answers. So angle R. So if we look at where angle R is, it exists at L. So let's bring up a diagram and extract angle R there. And why we're doing that, so we're looking at a particular rule that looks at what happens on the right-hand side. And this dart-shaped four-sided or quadrilateral figure that fits inside the circle looks similar to the first one. And what's the rule there? We have x and 2x. The rule states that the angle subtended at the circumference, which is R, is half of the angle subtended at the center. So R is equal to 156 divided by 2. So R is equal to 78 degrees. So easily we can tell that. And if you draw it yourselves, you can measure it, you can see that it doesn't matter what value you have at the center, it's always double the one at the circumference. And now let's go on to the next one, angle E. So if you look at angle E, that's the exterior of the triangle. So let's bring it up and extract. So we can see what it looks like, that the exterior angle of the triangle E, right, looks like the bottom rule there on the right-hand side. Opposite interior angle is equal to the exterior angle. And we can show it here. Let's bring up a red arrow to indicate where it is that E lies. And if we took that, whatever the angle is, and we translated it across and rotated it to fit, we'd see E and R are the same. And in part 1, R worked out to be 78. As such, E is also equal to 78 degrees. And for the next part, angle A. So if we consider angle A, it lies at M along the cyclic quadrilateral. So let's bring up the cyclic quadrilateral and extract it so we can see the rule and what we're speaking about, the opposite angles in the cyclic. So we have A, and let's indicate the opposite angle as being something purple. And the opposite angles add up to 180. They are supplementary. So we can see, and that looks like that rule on the right-hand side there. So you can go into the playlist and find that. Then NRL, which is a purple angle, plus A, the angle at NML, is equal to 180. And therefore, NRL, the purple angle, is 180 minus A. And we can also notice that on the right-hand side at R, we have three angles forming a straight line. So 180, which is a straight line, would be the angle E, plus the 48, plus the purple angle, NRL. And we know NRL is 180 minus A. There are many different ways to do this. This is just one of the ways. I've tried to use what I thought was the simplest. So 180 is E, which is 78, which we got in part 2, plus 48 plus NRL, which is 180 minus E. And now we can minus 180 from both sides. So if we minus 180 from the left side and 180 from the right side, it'll give us 0 is equal to 78 plus 48 minus A. And we can take the A on the right-hand side and carry it across. So we'll have A is equal to 78 plus 48. As such, we've solved for the angle A, which is 126 degrees. Let's now move on to the next part of number 9, where the question says in 9b, the diagram below shows a triangular field LMP on a horizontal ground. So we have a triangle there. And it's a bearings question because we see we have a north line. Calculate the value of angle MLP. And I have highlighted that in purple so you can see exactly what it is. Now, if you notice that we want to find an angle and we have three sides, so we can use the cosine rule, which is given in your formula sheet. So a squared is equal to b squared plus c squared minus 2bc cos a. And I've just substituted for a, the angle, the side opposite the angle. So as mp squared is equal to, any one will be b and c, ml squared plus pl squared minus 2 times the length of ml times pl cos l. And we want to find cos L, so we need to transpose ml squared plus pl squared. They're adding on the right-hand side. We could carry it across and they'll subtract. And minus 2ml pl is multiplying by cos L. So when we carry it across, it will divide. So I've skipped a line of work in here, but you can do it in parts if you're getting problems. And now we can substitute values because we know MP is 180 squared minus 150 squared plus 120 squared all over minus 2 times 151 times 120. So cos L works out to be 0.125. As such, the angle that we're trying to find, the purple angle L, will be cos inverse of that, which is 83 degrees. Make sure to remember that to set your calculators in degrees and not rad or grad. Those are not for this level at Form 5 or CSEC. Moving on to part 2, because of the bearing, let's pull out the idea that the bearing of P from L is 210 degrees. When we say a bearing question, the bearing of P from L, it means we're standing at L and we're facing north. And we're turning in a clockwise direction until we face P. So we have that indicated with that green arc to show that entire angle is 210 degrees. So let's repeat, it's standing from L, looking north and turning in a clockwise direction. So we know that entire angle is 210. And the question is asked us, find the bearing of M from L. So M from L means we're standing at L, facing north and turning in a clockwise direction until we face M. So we have that indicated with that red portion of a circle there, that sector. So how do we get that? Well, we know N, L, M which is the bearing of M from L, which we have in that red, plus MLP, the piece below, which is the purple angle that we found in part 1, that those two things add up to give us the entire green arc, NLP. And we can substitute because we know MLP is 83 degrees and NLP, that bearing was 210, that was given. So NLM, the red, is 210 minus 83, which is 127 degrees. And because you're asking us to find a bearing, then NLM is 127 degrees north. Normally, when we write bearings, we want to have 3 values along with the degrees and north sign to indicate that that's where we're starting from and turning in a clockwise direction. Part B, calculate the value of NLP. So let's extract that. We have NL and we have P at the bottom there. Its length is 150 meters, but we're not going to use that. And hence find the bearing of L from P. So the first thing to do is find the value of NLP. So this entire arc is 210 for given above. And we want to find the angle NLP, which we have there in green with a red arc on it. So if we add up those two, it will give us an entire circle. So that angle in green plus 210 is equal to 360. So we can carry the 210 across or minus 210 from both sides. So angle NLP, which is what we want to find, the first part, is 360 minus 210 degrees, which is equal to 150 degrees. So we know what that angle, the green one with the red arc, is. Angle NLP. From there, the question says, hence, meaning using the 150 degrees, find the bearing of L from P. So if we're finding the bearing of L from P, means we're standing at P, we're facing north, so let's put a north on it at P, and we're turning clockwise until we are looking at L. So we have that in blue. So that is what we're asking for the bearing of L from P. However, if we notice that from P, we have a north line, from L, we have a north line, so those two north lines are parallel. And if we have two angles within there, a transversal connected to two parallel lines, it means that those two interior angles, or we call it co-interior angles, when we add it up, will be equal to 180 degrees. They are supplementary. So the blue angle and the green angle in total is 180. And we worked out the green angle to be 150 already. So let's write that NPL, the bearing there, plus 150 is equal to 180 degrees. So we can carry the 150 across. So the bearing NPL is equal to 30 degrees. 180 minus 150. What we want to write it as a bearing, so we want to have 3 values. So we're going to write 030 degrees north. And now let's continue as we move on to the last question on the paper, number 10. And this part A is a matrices question. The matrices A and B represent the transformations given below. A is 0, minus 1, 1, 0, and that represents an anti-clockwise rotation of 90 degrees about the origin, O. B, 0, minus 1, minus 1, 0, represent a reflection in the straight line, y is equal to minus x. Part 1, determine the elements of the matrix C, which represents an anti-clockwise rotation of 90 degrees about the origin, which is the matrix A, followed by a reflection in the straight line y is equal to minus x, followed by B. So A happens first and then B. So how do we do that? Similar to when we're writing functions, we write the function A on the right-hand side, and then the composite function B will be to the left of it. So it will be BA, which is, if we substitute from above, 0, minus 1, minus 1, 0, multiply by 0, minus 1, 1, 0. The matrix B times the matrix A. I've color-coded it so we can remember, give us a little hint on how to multiply 2 by 2 matrices. So the rows in the first matrix are multiplied by the columns in the second matrix. So the rows are red and green, and the columns in the second matrix are blue and black. So the first row multiplied by the first column will be red times blue plus red times blue. So it'll be 0 times 0 plus minus 1 times 1. And then for the second element, it'll be the red row by the second column, which is the black column. So it'll be 0 times minus 1, red times black plus red times black, minus 1 times 0. And then for the third element, it will be the second row times the first column, which will be green times blue. So it'll be minus 1 times 0 plus 0 times 1. And then the second row times the second column to give us our last element. Green times black, minus 1 times minus 1 plus green times black, 0 times 0. And now it's a simple solution. The first column by the first row, which is our first element there, will give us 0 plus minus 1. And the second one will be 0 plus 0, and then 0 plus 0, and 1 plus 0. And it simplifies quickly to minus 1, 0, 0, 1. So this will be equivalent to the representation of applying A to a point and then B. Now, in part 2, describe geometrically the single transformations represented by C. So C is equal to B times A. So what is this minus 1, 0, 0, 1? If you want to recognize that, if we apply this 2 by 2 and multiply by xy, then we will see what happens. It becomes minus xy. So all that's happening is the x value changes from positive to negative. The y value remains the same. So that's equivalent to saying that we're having a reflection about the y-axis. If we reflect anything about the y-axis, the y values remain the same, but the x value just changes sign. And let's go on to the last part of the matrices part of this question. A transformation T is defined by the following matrix, right? So this 2 by 2 matrix is 1, 2, k minus 1, where k is some constant. T maps the point 2, 3 onto the point 8, 15. So if we take 2 and we multiply it by 2, 3, it will give us 8, 15. So we can determine the value of k. Let's now determine that T by 2, 3 would be 1, 2, k minus 1 multiplied by 2, 3. So we have it just as we did with the BA, rows by columns. So it'll be red row by the black column and the green row by the black column. And we know the answer 8, 15. So it'll be red by black, 1 by 2 plus 2 by 3, and then green by black, k by 2 plus minus 1 by 3. So 1 by 2 is 2, 2 3s are 6. So you're going to get 8 on the top right side is equal to 2k minus 3. And if we compare the first elements on both of them, then 8 is equal to 8, that's fine, and 15 is equal to 2k minus 3. And that way we have one equation and we have one unknown, so we can find the value of k, which is what the question is asking us to do. So we have minus 3 on the right-hand side. We could add 3 to both sides. So we get 15 plus 3 is equal to 2k, because the minus 3 plus 3 will cancel. 18 is equal to 2k, so we could divide by 2 on both sides, so k is equal to 9. So we've determined the value of k. Now we go on to the last part. In the last question, it says the following vectors are defined as shown below. Wx, 5 minus 1, which means this is a direction vector, and where we are at the position W, we have to move 5 units to the right and 1 unit down in order to get to the position of x. And similarly for xy and zy. So let's bring up some random points, w, x, y, z, because there are 4 different points indicated in this question. And this is just to give our students a general idea of what's happening. So if we're moving from w to x, that column vector, 5 minus 1, indicates such. And then x to y was given, and also z to y was given. Determine each of the following. Part 1, a vector other than 5 minus 1 that is parallel to wx. So there are infinite solutions to this. And we can just say, if we consider multiplying wx by minus 2, it means it's a vector which is parallel to wx, but 2 times as long. And in this case, we are seeing it's in the opposite direction. So that's why I'm multiplying by minus 2. Any value you put to multiply by instead of minus 2, minus 1, 5, a half, all those will also be vectors which are parallel to wx. So minus 2 times, what is wx? The column vector 5 minus 1. So if we multiply minus 2 by 5 will give us minus 10, and minus 2 by minus 1 will give us plus 2. So that is one possible vector which is parallel to wx. Let's move on to part 2, WY. So if we want to go from W to Y, let's indicate that with a red arrow. We can pass from W to X and then X to Y. So let's write that. And one of the things when we're writing vectors, we can see that on the right-hand side, that X is connected to X. So now let's substitute 5 minus 1 plus minus 3, 7. 5 plus minus 3 is 2. And minus 1 plus 7 is 6. So WY is 2, 6. Let's now go on to XZ. And if we're looking at X to Z, let's bring our arrow to show that. We can pass from different routes. We can go from X to W, W to Y, Y to Z, or we can go from X to Y, Y to Z. So let's use the shorter route. X to Z, we can pass from X to Y. We start at X, we go to Y, then we go from Y to Z. Now, if we look at it, we're given XY, but we don't know YZ. We know ZY. What's the difference? It's the same column vector, but we're going in the opposite direction. So in order to correct it, we can say XY minus ZY. The opposite direction means we can multiply by minus 1. So we can now substitute minus 3, 7 minus 8 minus 7. So to work out XZ will be minus 3 minus 8, which is minus 11, and 7 minus minus 7 is 7 plus 7, which is 14. Let's go on now to part 4, where they're asking us to find the modulus of xy. What is modulus? Those two parallel lines that's vertical, what does that mean? It means the length of the vector xy. So if we use the same green arrow to show us from x to y, and we consider it to be a right angle triangle, then if we want to find the length of xy, it's like finding the length of the longest side. And if we consider it to be a right angle triangle, then we can say that we're using Pythagoras' theorem. So xy, if we looked at it, we saw the column vector was minus 3, means we're going 3 to the left and 7. So remember that it's not facing the correct directions, but we're just averaging from it. So students get an idea that the x value is minus 3 and the y value is 7. So if we want to get the hypotenuse in this case, which is the length of it, then we can use Pythagoras' theorem, o squared plus a squared is equal to h squared, or any other version. And we know the two shortest sides, so we can substitute. So it's going to give us minus 3 squared plus 7 squared is equal to xy, the length of it squared. And minus 3 squared is 9 plus 7 sevens are 49. So that'll give us 58 is equal to the length squared. So if we want to find the length, we get the square root of 58, which means that is 7.6 units. So the length of xy is such. So we've now come to the end of CSEC past paper questions, and specifically paper 2 for the year May 2023. All the years before, from 2009 until 2022, those years were subdivided by topics and were stored in particular playlists. So all the questions dealing with circle geometry, there is a playlist for that for those years from 2009 to 2022. And there were also notes in the playlist as well for students to follow. And this is done for every single topic in CSEC Math. So you can go through it and identify. The next one we're going to do is May 2024. So don't forget to look at the description down below where we have identified all the playlists and the order we suggest you go through those topics in order to get a better grasp of the CSEC Math syllabus. And when you're finished, then you can come to this list in which we start to do entire past paper questions, all being paper twos. Have a good day, everyone.